If you want to log in.
Overhead?
I have enough. This is washing me out.
That's why I suggested overhead.
That might be worse.
Try it.
It's quite a bit better. Ah.
Sasha would like to get up with you, or in the bed. She doesn't know which, she just wants one of them.
Cool.
Try turning on the light. I want to see what it looks like.
Turn it off. That is so much worse.
Yeah.
Absolutely not. Oh, hello.
Maybe point the other light.
Hi, Jess. Okay.
Point that light towards you.
No, it's fine. It's not a big deal. I'm just testing. Thank you. I also love the bench. Today, we're working on an airsoft gun. I don't have my mallet. I make this thing rip with some different gears. Should have a good time with that. We have winter lo-fi in the background because it is extremely snowy outside. And my lovely partner has made grilled cheese and tomato soup. Sometimes you just need diagonally cut grilled cheese and something to do, you know? I did drop them a little bit. How's this? We should be going through my Yeti mic right now. The Yeti X is pretty hi-fi, but doesn't have a very good pass filter on it. It's our very first go. Eventually, we'll probably get an overhead mount up here for probably so you can see my hands. I think that'd be a lot better. But
You could try connecting your other webcam.
yeah, but then I'd have to unroute the cable from where it's at right now. That's a pain in the butt. I cable manage with zip ties, not a two-sided Velcro. That's the wrong Allen key. Hello, Tenenbaum. Thank you for attending the test stream. Oh, we are not sacrificing things to the hardware gods today. How's my voice volume? Can you guys hear my voice okay? I'm actually really far from the mic right now. It's next to your point of view, not in front of me. See how far. Can't beat tomato soup and grilled cheese. No, you cannot beat a tomato soup and grilled cheese. It's, in my opinion, the unbeatable combo. Well, besides maybe Scotch and peppermint, Avalor 16 and peppermint's pretty good. A demagnetizer. All right. Currently working on a soldering mat I got as a gift from a friend. I jokingly said, "Hey Adam, get me a soldering mat for Christmas," and then I, ran along with the joke for a couple more steps and handed him my address and whatnot. And then he told me it was arriving the next Friday, so now I have a really nice mat. Thanks, Adam. But it does really help because when the tiny little parts try to roll away, that little lip is just enough to stop them. That's right, you did have the 12 with that mint. This is exactly what I needed. Thank you. You are the best, and I love you.
I love you too.
I'm trying to do most of the eating before I get into the gearbox. Because once I get into the gearbox, my hands will be covered in that nasty, dirty grease. And I'm not keen on ingesting PTFE filled with metal. Not really my thing. Need some punch
Is
marks.
it anyone's thing? Question mark.
Have you ever met a grease monkey?
That's fair.
Those dudes live on like chemical fumes and spite. Fun fact, I've never actually had an after 8. What kind of mints is an after 8 exactly? All right, come out, little pin. Hey, I punched it from the right side. Look at me. It's one of those funny pins that has ridges so that you can only really punch it from one side. Unfortunately, they're quite small. It's a dark chocolate wafer. Oh, yeah, like an Andes mint. Okay. We have those on my bench because I love them. Those look like an after dinner mint, right? One of these guys? Very thin. I think I'm probably right. Get the stock off. No after 8s in the. I don't know. Maybe. Maybe Andes is just like a competing brand. Andes is what I've known. Andes mints. They're like a little bit of dark chocolate. No, actual cook. Oh, so they're completely different. Well, mostly different. Yeah. So Andes mints are just dark chocolate with like, I think it's probably mint white chocolate in between. Still really delicious, but obviously not an after 8 if it's got, a little cookie in there. Maybe a 1/4 inch thick. That's a nice and substantial little bit of a mint hardware there. I must say this stupid thing. Wires. I call it a castle nut. And now I must gently undo that castle nut. Okay, now. It is okay. Whew. Alright. Castle nut is undone. Now, the real challenge is getting it rethreaded. Little sling plate, sling attachment.
Would you like me to grab my webcam?
No, it's okay. What am I caught on here? Caught on something. My own hubris, perhaps. 1, 2, 3. What is preventing you from moving, little dear gearbox? Why are you stuck? Oh, I'm an idiot. Motor grip. Thank you. This motor grip is actually connected to this gearbox. I'm like, why isn't it coming out? Oh. It's specifically built not to. Fun little 2 mil grub screw. Fun fact, almost impossible to machine accurately. See you in a bit, Jess. These are fun and easy to lose. I can disassemble that over the mat. That's it. Right. Our grub screw is free. Now, take our cute little baby pliers, pull up the motor. Quit doing that. And then we pull off these tiny little baby motor contacts that are unironically some of the easiest things to destroy I've ever worked on in my life. In my opinion, aluminum motor contacts are a crime against humanity, but that's an argument for another day, I think. Come on, there you go. All right, she's free. Now we can take out the motor. This thing is hilarious. So these are little really tightly wound motors. But the thing is, there are neodymium bell end magnets in there that, I mean, like, just eat your tools for breakfast. So you gotta, like, isolate these things. They basically have to go in solitary confinement. How about not next to my wallet? That's a bad place for a strong magnet. Onward and upward. I need a tool. You get in here and you take out these cute little screws that are like pan-headed, but they're also flat. Hard to explain. But there's 4 of them, and there's a little motor cage in here that ensures that the pinion, oh, come on, let go of my stand. Here goes that magnet again. That little pinion gear at the top there is ensured to mesh correctly with the gearbox through use of a cage built into the motor grip. This piece just makes the angle nice and correct. So as effective as the system is, those screws can be an absolute turd to get out sometimes. Very inconvenient. Because they're tiny, but they're also number 2 Phillips. Which I don't know if you've ever tried to align a number 2 Phillips. See that closer. You know what? That's not a bad idea. I can probably move my charger. I'll just have to disconnect my mouse and bring everything forward. Tell you what, I will finish that sandwich and I'll move the laptop up here because I have 10 outlets on this bench and getting you closer probably won't be a problem. Let's see if we can get you a good angle. Should be mindful about where I'm putting my tools. Probably can't see anything. Yeah, that'll work. Alright, come on, little screw. How'd you come? Getting very close to the stage where I can no longer use my hands to eat, so we're going to finish this. No longer eating implements. Take care of my plate. I'll be right back. Okay, let's negotiate this thing. Unplug that charger. Unplug that mouse. Guys, sorry if my voice is going to get super loud. We're working here. Okay. Get you a little closer to the work. That's not so bad. It's not perfect, but it's okay. How's the voice? Is this too loud, too soft? This is also my built-in webcam, so quality's not going to be great until I can get something else. Shop towel on here. Wonderful. All right. So, like I was saying, where's that motor? Here's our motor. There's a little pinion here. Let's see if I can get there. Now you can see it. There's a pinion gear there that meshes with this bevel gear, and obviously that angle is pretty sensitive where those teeth meet. So yeah, what that motor grip does is those 4 screws that screw into this metal gearbox here. There's a cage in here that serves 2 purposes. One of them is to ensure that that angle of the motor meeting that bevel gear is correct. And the other one is to suck some heat away from this, because this is still DC. You know, brushes and all, so that can be a little bit hot at times. Because we're cycling probably 120 pounds of spring tension a lot of the time. That's what I use anyway. Which sounds like a lot, but truly it isn't. It's pretty well contained. It's also 120 pounds of spring tension in a cylinder that is only about, I don't know, 3 3/4, 4 inches long. It's not a very big cylinder. Nice workspace. Thank you. I'd actually spent quite a lot of time thinking about this before I had the chance to build it. So I'll move my little TI-30X timer here. This is actually a soldering station. It's temperature controlled. I got really tired of replacing bits on those ones that just pump like 80, an unregulated 80 watts through a heating element. Believe me, it gets very, very old buying a new tip every week when you've got things to solder. So yeah, that's the KSG RT12 temperature controlled soldering station. It's nice and little, but it holds temperature within 2 or 3 degrees, gets up to 350 C pretty quick, so serves my purpose as well. Mostly I'm just soldering things like beans connectors under the ends of batteries. I don't need a whole lot. Let's see if I can get that. Ooh, we got another one. All right, last one, ladies and gentlemen. Can he do it? The real question is not whether or not I have the skill tactilely to remove a screw, but whether I have the wherewithal and patience to align a number 2 Phillips down a hole that is almost exactly that size. Oh, I got it. Yeah, this soldering pad actually was used for laptop repairs recently and will be again used for laptop repairs quite soon. What I'm working on right now is an MSI Prestige 14 that while we were dinking around in here, something went flying and gave the LCD a tiny little nick. So I actually have a screen replacement we're going to be doing pretty soon. All right, come on, little guy. Out you come. How's my audio quality? It should be fairly acceptable because I should be, or at least I would hope that YouTube is detecting my Yeti X. Sometimes I have concerns that doesn't happen. Come on, little guy. Ah! Haha. So about this soldering mat. This is both grounded and then the hardware areas are magnetic, which is really, really nice when you have little tiny Ferris screws that look to work their way free of things. There we go. I'm going to pull those motor contacts out of a pair of really little holes there. And they're aluminum, not copper, not steel, so repeated bending is bad. Let's see if we can see those. Yeah, so the top and bottom holes. Yeah, those top and bottom holes are where those motor contacts go through. And these are aluminum bent at 90 degrees, which you can imagine is probably not the best for strength. Hello, Dauber. Welcome. All right, motor grip goes away. Should be able to pull this gearbox out. All right. Fun part. Almost fun part. This is actually just a scary part, if I'm being honest. So first things first, all these little Phillips head gearbox screws got to come out. But for that, we use a number 1 Phillips. And we're actually going to be replacing these. So I got much nicer ones. The ones that are in here are just normal carbon screws. Actually, that's not the first thing I need to do. The first thing I need to do is to let off the spring tension and pull out the compression spring. So we're going to do that so that I don't get shot in the chest with it. This is not a Phillips. This is a hex nut. I believe it to be a 5mm. Let's see. No, it's not. It's 6. So in here, a little spring guide. Be careful about my tools. I keep doing that. A little spring guide and a little catch system, which I think you can see. So you push this in and you turn it 90 degrees and out comes the spring guide and spring, which is important. And the reason that is important is for the purpose of removing the gearbox shell, clamshell style. When you take things out, you don't want that spring tension exploding in your face. I've done it. It hurts every single time. All right. So what's in here are just normal cheap Chinesium machine screws. See if I can show you the difference here. Got one of these. Just your common, not nitride. I can't remember. It's that black oxide coating. What the name of that is. The cheap Mish metal stuff. What I've got to replace them are some stainless M3 machine screws that are a little tougher. They've got a thicker head on them as well. So those will stay much better in the gearbox. Every time I work on one, I tend to replace those just because these heads, you look at them funny and they strip, and then you never get them apart again. All right. I tend to keep these for spares just in case of an emergency. Like if in the odd chance that these holes for some reason aren't that M3 standard, it's good to have them. We'll do a quick test and make sure that they are. Let's turn that down. Are you M3? I didn't feel resistance, so we're going to say that those are M3 by 50. Out you come. What am I tearing apart? This is an airsoft gun gearbox. I work on airsoft guns. I started way back in like 2014, just as a kid. I liked to play. I wasn't really teching very much back then. But one of my friends was like, hey, you might like teching. The tech is a lot cooler now. There's a lot of programmable micro triggers and whatnot, and things are cooler than they used to be. So it's like, oh, whatever, I'll try it out. He was right. It's definitely way cooler and way more fun. And the tech that comes in these things nowadays is just honestly kind of insane compared to what I had. Even the trigger unit I've got in here, I programmed. Like it's not just mechanical. So, ooh, there we go. That little buzz you just heard was the anti-reversal system not doing its job, which was on purpose. That's what this little guy did. I went in here and pulled out a latch, or tripped a latch rather, which prevents gears from reversing. And the goal of that was just to make sure things could come out the way I wanted them to. What I'm doing right now is testing for shims and then removing them. So shims, I have a bag of them around here somewhere. Where's my shims? I hope they're around. There they are. Sorry, I had to change your guys' view for a second. Shims are these little washers. What these are very finely machined washers. And these are machined to within really close tolerances by a company called SHS. These are, I believe, 0.1 millimeter, 0.2, and 0.5 millimeter. And we put these on the gear axles to get rid of up and down play in the gearbox. That just helps the system work more efficiently. Sometimes bushings and bearings will be a little high in the gearbox. You'll get gears like this that can sit really low. Let's see if I can get you a side profile there. That can sit really low, and then these teeth on that gear will chip on a bushing, because bushings are very, very hard, and it'll eat up your gear teeth, and then it won't work at all, which is stinky. Nobody likes that. Here we go. Shims detected. Top of the gearbox shell always goes to the left. One of the standards we work by is we always work from the bottom part of the gearbox shell. So if you've got it facing this way, it's the left. We always just clear out the top, put it away. The only time we fool with it is when it needs to be cleaned, which will be way later in this process. One of the things I'm looking for is excess wear on parts of the gear. And actually, I am seeing some of that. I'm seeing wear on specifically this bevel gear. It's not looking very good. I'll see if I can put this up here. Oh, perfect. It does show. Let me get my little pointer here. You see that line in there. This is a lot of really excess bad wear. It's probably from bad positioning of the motor relative to this, which is called the bevel gear. This one, as you can see, actually has a machined cutout to prevent some of that wear from getting really bad at the top of the teeth. I'll show them side by side. So this bevel gear, the teeth are just straight all the way to the tower. This bevel gear is machined with a gap into the tower, which is much, much better. We like that more. So cheap bevel gear, not doing too good, kind of getting eaten up by my O-type pinion up here, which is funny because the O-type pinion is actually looking pretty clean, which means that this is a very, very nice hardened chromoly pinion, which is what we like. But that's why we're replacing these. We know that these are not the best of quality. So let's take apart our compression system. This is our piston. I actually can show you in half how this works. It's kind of fun. So I've taken out the motor and the bevel gear. Bevel gear sits here. Turns this spur gear. Motor's going. I think you guys kind of get the gist. So what happens, let me get this neatened up here. All right. So what happens, this is called the sector gear. The sector gear will turn. Once I get this anti-reversal latch out of here. Sector gear will turn. And it'll pick up. Oh, Lord have mercy. What's it doing now? There it goes. I'm going to take this compression system out. Well, I was going to show you, but now it's being finicky because it probably have loose shims. Anyway, this sector gear will turn in that direction. It pulls this on a metal rack. It's on the bottom of that. Probably not visible, but we're working on it. Once it reaches the end of that long rack, sector gear will turn down, and that goes forward, and spring tension compresses the air in the cylinder. Air goes out, BV goes down range. That's kind of how they work. We're going to remove the compression system because I have things to do. Out. So these other non-keepable gears will go up here. These are the brand new ones. These are chromoly steel. I've actually had these. I've seen these in other guns. They're able to chew through gearboxes if something truly does go wrong. So they're incredibly strong. What I'm doing right now is just looking around for extra shims in the gearbox that shouldn't be there. Anything like that. Looks like we've got a loose bearing here. Such is life. That's why we don't like bearings. We like bushings in this family. Bushing family only. We'll actually be replacing those. Pulling the rest of the shims off of the sector gear. So this is what we're talking about when things get shimmed really badly. What I've got here is a piece of a bearing that worked itself loose. And bearings are bad at handling high stress under these kinds of numbers. It's just the way it is. Unfortunately, this bearing decided to give up the ghost under the amount of pressure that was there. So it's going to go away. I've actually got to remove all the bearing balls from inside of this thing, which is going to be a pain in the butt because I can't use a magnet because I have a trigger control unit in here, and that's computerized, and the data for that is stored on a magnetized chip, which means magnets will ruin everything. Which is why when I get inside of this thing, I'm using this tiny little demagnetized guy that goes in a very specific spot up here in a hole that doesn't have a magnet strip below it. We don't mess around with ruining that stuff. Too expensive. This tiny little chip right here, right? I mean, this is maybe an inch by an inch and a half. This little trigger control chip costs, I want to say, about $70. And it does use tiny magnets in its operation, but not like pulling things out magnets. There's a Hall effect sensor, which I don't want to really get into trying to explain the Hall effect at the moment, but enough to say it depends on a magnet to do its sensory things. So if we magnetize parts, things go bad. But I'm seeing some, I don't know if I can show this on camera, if this will show up. There's a dark line in the gearbox right where the motor meets the bevel gear. Oh, you can see it. There you go. Where the motor meets the bevel gear, this is that shaving action from the really cheap gears that we were talking about. We're going to have to clean all that out so it doesn't get in the new grease, which I have ready to clean here. We're going to be cleaning this unit with isopropyl, 90% or above. Otherwise, we risk damaging that chip, which we don't want to do. But first, I have to get out these punch blocks and punch out what is left of that stinky, messed up bearing. You've betrayed me, bearing. I do not like you. Come to me. Disrespect me on the day of my daughter's wedding. Oh, this is going to be a fun one. Okay. Trying to position this in a careful way such that the chip isn't at any danger of being, compressed or punched or anything like that, because that would be a really expensive mistake. Yes, exactly like inexpensive joysticks, actually. Let's see if I can get this out. So what I'm trying to do first is punch it flush with the gearbox shell and then punch it the rest of the way out after that. This guy's in there pretty good. There it goes. Finally. All right. So as you can see, what I have here, I wish I had my forceps on me. Unfortunately, I don't. So we're going to go with the old, finger method. These will work. These are a pair of mini pliers. So what we have here is half of the races of a bearing. As you can see, there are no bearing balls inside there. Nothing. Which is obviously a problem. This is why I'm opening up this gearbox, by the way. It needs new gears, and we're going to put in bushings instead of bearings, because the bearings in here positively suck. All right. Bearings are going to come out. We're going to get rid of this. This is just garbage now. Take big things like that off the bench so that they don't get mixed in with good parts. Now comes the fun part where I put on gloves to avoid any actual static discharge. We're going to use nitrile. Some people say that nitrile doesn't avoid static buildup very well. They're wrong. I use them all the time. And with this level of resistance, I mean literally static stuff, it's almost nothing. This is a silicone mat, which does have some surface generation of static, but this mat is actually grounded. And so am I. That's why I'm not really going very far. But we do ground ourselves when we work with this stuff. A lot of people are saying, why don't you do this for money? Well, Adam Savage from Mythbusters. I don't know if any of you know of him. Some of you probably do. I figure we watch similar shows at least. Once said that once you develop a business relationship to a thing, your pleasurable relationship to it will change in such a way that you probably won't get the other one back, which is true. And this is one thing that I would rather just have a pleasurable relationship with, because I really love specifically airsoft teching. Machining, I would love to do the work in. I actually made these precision punch blocks. These are within 2/10,000ths, not 2/10 of an inch. If I say tenths, that is what I mean. They're within 2/10 of each other. They were milled and surface ground and checked for square and all that. This square is within 2 thou. I just didn't need something very precise. So we've got our isopropyl out. I'm going to move that so that you can actually see what I'm doing. Cap back on. Just going to try and remove a lot of this old grease from the races and everything. Get all that ground up metal off of the bushing and bearing openings, so that when we do go to epoxy in the new bushings, we don't have shavings of old cheap gears in there. It's a fun rule that I have that I don't break open and make inoperable more than one gun at once, because I want to have one to play with. See if I can show you some wear here. So this is the one that was stuck in that bad bearing, and I can see there's a lot of excess wear because some of my shims here are indeed made of steel, and what happened is that bearing jammed up pretty bad. It let go, and once those bearing balls got stuck and outside of their races, this was spinning on only the inside surface of the other half of the races, obviously, and not having that surface spin with it, which means it was spinning on top of the shims too. Hopefully that ring around the middle axle will show up there. It was starting to eat into the gear. Yeah, it's showing up. It was starting to eat into the gear. And you can tell when these things are operating by how they sound. And this one was giving me some excessive gear whine, so I knew there was a lot of stress on the teeth. So I started suspecting some things. Shot it a couple of times, took it out, tried to do some investigatory work. And lo and behold, wouldn't you know, the teeth were buggered because of that shot bearing. So that's kind of what we're removing here. A lot of the times I'll find errors in some of the gearbox tolerances, and I will have to Dremel them out, which is what you guys can't see it. It's right here. I have a Dremel on a stand with all of its bits and whatnot. This is one of those nice little stylus ones. And I'll actually have to Dremel out areas of the gearbox to make it run the way I want it to. Ooh, we got a little bearing ball in there. Get out of there. Come on. Let go. Come on, little guy. Beat it. Those are going to be a pain. It's going to be miserable to get all those tiny little bearing balls out. I'm pretty sure these bearing ball sizes are 1.5 mil, which is tiny. That's the kind of thing that the hardware gods eat for breakfast. They demand tribute every now and then, and that is one of the things that I must tribute to them, is small bits of important and useful hardware. So this here is a selector plate where that old bearing was. There's bearing balls and grease jammed up in it, so I'm going to have to remove this safety latch here. Get that plate off. That'll have to go in one of these hardware bins over here. I'm going to clean one out real quick so we don't really get that gummed up. Isopropyl's pretty good at taking the shmoo out of silicone surfaces, I've noticed. So we're going to use a little bit of isopropyl. Again, this is 90% or above. I've got 91 here. Just kind of what was available. Sometimes you can go to the hardware store and get a big thing of 100% or 99%, something like that. That's expensive though. And for some reason, I find it doesn't actually work that well. Maybe someone who's more educated than I can tell me if they put something else in it that would make it not be as suitable. Throw this away. Okay, we have a number 1 Phillips panhead screw. Sorry, I bumped that microphone if that caused a bunch of noise. So when I take out that screw, I check the magnetized tip because it almost always comes out with it. Can't help that. Now this will have to be pried off. So what I'm going to do is put my tiny little screwdriver in the gap between the spring and that lever. And put my thumb over top of it because that spring loves to run away on us. I have lost 3 of them and refound 2. I actually have one I refound right here. It goes in the extraneous hardware bin. All 3 of those parts go in their little thing, and they don't come out until it comes back in. Now this selector plate can come out, but there's kind of a bearing balls jammed inside of it, so we got to be a little bit careful here. I'd love to show you on camera what I'm doing, but unfortunately, you've got to prioritize making this work again over showing it on the test stream. So there's a set of like tracks that this thing goes in, and I actually have spare stickers just in case this does have to peel off in the course of getting it out. There's tracks that this plate will stick in that I'll show you once I do get it off. They get really tight when you get things jammed in them. And that was a big part of why we couldn't get this thing to work. This selector was jammed. The remnants of a broken bearing. Let's see if we can pull it off. Lift the plate. Right now we're just trying to get that selector plate out of its tracks. There it goes. Perfect. So that sticker did actually tear up because of those bearing balls getting stuck in there. Remnants of a broken bearing. It's not bad. That is a pretty good band name, actually. So that sticker right there, that white stripe on there, is what that light sensor senses for where we're at in the selector plate position. And that tells the airsoft gun, is this full auto? Is it semi-auto? Is it safe? Yada, yada. This little lever, actually, that the plate was actuating in front of, that we just took off before we removed it, is a physical block for the trigger when you get into safe mode as well. I leave that in there when I put in these trigger boards just because I think it's a safety thing. I mean, you're not really going to kill anyone with an airsoft gun, but it's still, you know, better for the sport that everyone is as safe as they can be. And another bearing ball. Go away. God, that really gummed this thing up. But anyway, I'll get around to showing you those tracks. So these are these tracks, these long castings, and this is what that plate was riding back and forth in, and that's where that exploded, torn apart bearing was at, and so it was all up under here. So now comes the cleanup work. This sticker is destroyed. Let me see if I can find my spares. There's the spares. So on here, there's a bunch of stickers that do the same function that I'll replace that guy with right there. I keep the manuals and the stickers every time I install one because they provide you with spares for just such a situation. It gets really frustrating, especially when things don't work like they should. It's because you forgot to keep parts. Let's just keep these nice and close to me. Metal band or emo. Remnants of a broken bearing. I'll be honest, that sounds like something in between, kind of like emo, like hard emo, maybe, if that's a thing. Alternative emo, perhaps. So I'm going to take some isopropyl now and try and clean out some of that grease where the shavings of those bearing balls were and the races, and just get that kind of out of there. Having that in the tracks was just such a pain. Outside of the paper towel, I'll actually take this demagnetized screwdriver and just manually pull out little bits of dirtied grease. And then the isopropyl tends to actually work its way in there after all is said and done, and does a pretty good job of dissolving all of that away by the time I get back to greasing the new bushings and bearings. Yeah, these aren't great. Itchy arms. All right, back in your place, little demagnetized screwdriver. Put our bench blocks back up. Punch goes on a magnetized strip right next to me that sits next to me on the bench so that I can just take these things and pull them out. I've got the gearbox shell in my hand. We're going to wipe this surface so that I can kind of, as you disassemble these things and they've got damage, you get tiny little metal shavings all over this work mat. Yeah, I don't know if that will sparkle for you guys, but I can see all the metallic sparkles on this thing. Fallout Boy. I don't know. Fallout Boy might even be a little soft. Maybe My Chemical Romance, that level of emo, you know? Let's get some of the shavings out of here. Yes, I am being careful to see if I missed any important hardware. That's a constant concern of mine. In fact, this trigger assembly, I'm going to clean out that last little bin over there. And we are going to... I'm going to go ahead and put that in there so it doesn't get lost. Just having some fun, gentlemen. All right, so that's in there. Let's take a look at the other half of the shell. Yeah, there's definitely remnants of motor wear. I can see it where there's grease with a bunch of caked on shreddings of that poor bevel gear. Not looking good in there. Jeez, I really did a number on this thing. So we've got this thing pretty much all the way apart. Now it's time to punch out the rest of those bearings, because these are going away. If one broke under normal gearbox stress, the other ones are bound to. Out. Out. And I'm being pretty careful to not nick the edge of that hole. That would prevent me from getting in bushing. That one's out. So, because they didn't have floor space. Probably true. So I know I did a good job getting these out because the races stayed intact. If these were getting torqued one way or another, these races would usually break. I've had that happen. Put these all over in the corner. Check my fingers for little bits of grease. The tear in the glove. I'll have to replace this in a couple of whacks there. So we clean these holes out. And one of the things you'll see me do is I'll get my calipers out in a second, and we'll measure these holes, because these bearings come in a variety of sizes. They come in no, they don't come in 1 mil. They come in 6, 7, 8, 9, and 10 mil. And bearings and bushings will go in the same holes as long as you get the right size. And when the difference is literally a millimeter, I'm not going to sit there with a drill guide and a super precise drill just to get the right size hole. I'm just going to buy the right size bearing. This is the one I'm worried about. You can see that chip is really, really close to the edge of that bearing. I'm a little cautious on playing whack-a-mole with that, but we're going to see what we can do. This is where those punch blocks come in handy. I can stabilize the gearbox on these on strong areas. And kind of give myself a little more leeway in my punching. So we're going to punch close to that chip first and just kind of tap it out ever so gently and try not to cry. Someone please gently cup my underside. This is a scary moment. Very easy to muck up a build by going too hard right now. It's starting to get low. I think we did okay. Ladies and gentlemen, we are indeed okay. I didn't destroy the gearbox, didn't destroy the trigger. In fact, I don't even think the trigger board got any contact there, which is what we're hoping for. We use those bench blocks a lot. See all these wires hanging out. I don't know if I'll have time to show. I hope I do, because it'll be fun. All these wires hanging out. There's actually channels in the gearbox for me to run those in when I get it fully assembled later on. A little bearing. All right, last bearing's out. Cheap bearings, no bueno. Cheap bearings are stinky. So we've got to clean this bad boy up. And I actually probably need to make a call and check on bushings. I think these are probably, if I had to guess, 8mm holes. We're going to look. All right, so we're going to keep one bearing. We're going to clean that bearing up. And so we can get a more accurate measurement. Gently. Whack, 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 whack. Yeah, I know. Relative terms. You can give me a break. It might just be the mic because it's on the bench too. Picking up all that sound. All right. This is where I get to show off. Because I like to show off, to be entirely honest. I do have the holy grail of calipers. No, they're not Harbor Freight calipers. They're not even Brown & Sharp calipers. Gold standard. Got Starretts. We keep them in the case, and we keep them clean in the case. So, first thing we do, we indicate our calipers to 0. These are at 0, and they're indicated correctly. So we take 2 measurements. One is the minor diameter of the bearings. That's what it sits in the hole as. And we don't use a whole ton of pressure. And what I'm reading right now is 415. So we're going to get out our handy-dandy notebook off our board here. Grab a piece of paper. Now take over my channel, Jess. Hold that number in your head. 415. I still read 415 after setting it down. It's a good thing. So the first minor diameter is 0.415. That's a little off, actually. Just barely. 415, which I'm pretty sure is pretty darn close to 8mm. I'm actually going to use this laptop for my conversion. 2 inch. All right. I put in there 0.415. Huh, how about that? Might be 315. Did I misread this? Let's reset. I don't think I did, but you never know. Crossing back. Yeah, I absolutely misread that. That's funny. It's 0.315. I'm behind the 4 line. I think that's, yeah, 8.001. Oh my gosh, I'm good. How much did these cost? I'll be honest, I don't want to talk about it. I don't want to talk about it. Well over $100. These were actually a gift. I think these particular Starretts are a little bit north of 2. I don't remember. But they were a gift, and they are a wonderful gift. And so we put them back in the case, having checked that there's nothing on them. So these being 0.415, which is 8.001, tells me that there's a loose tolerance here to 8 millimeters, which makes sense. You have to be able to fit them in, obviously. But that's okay, because when I put in the bushings, I'll probably JB weld them or epoxy them in place, because bushings don't shred. These are a brand called Siege Tech. I've actually seen these, I think I said at the beginning of the stream, I've seen these be able to chew through gearboxes before, which is insane. I do not fear the having of Siege Techs, because they're good for that purpose. They do a good job. They're strong. They're machined correctly. Actually, I don't remember what the term is for very, very small TIG welding, but these are fusion welded in 2 parts, heat treated beforehand individually, checked for flatness, and then that bead in there is fusion welded. There's no fill. It's just the 2 surfaces so that they mate cleanly. And as far as I know, I'm not an expert in metallurgy, but I believe chromoly steel is one that responds well to that process. So we throw away this bearing now that we've verified our size. And we put these exactly back where we had them. Starretts are beautiful. Mwah. Thank you, Uncle, who bought me those. I will cherish them for probably the rest of my life and possibly not ever need another one. Another thing that's going on here is compression. Now, let me just toss that. So one of the worries about compression that we have is we want to test and see whether or not we've got faulty compression. This O-ring was greased with white lithium grease last time, which is not good. We don't use that. We are not a white lithium grease. We are a PTFE and silicone family, which I have here. This is synthetic silicone grease with PTFE additive. This is pure silicone oil. That's what we use, because that's what you should use. Both synthetic and natural O-rings tend to like that a lot better. Petroleum and petroleum-like and petroleum distillates, actually, as a matter of fact, will dissolve most O-rings unless you get chemically non-reactive O-rings, which cost an arm and a leg, and we don't buy them because that's stupid when you can just buy that. I have a little bit of an attitude about airsoft techs who do things wrong. I am of the opinion that if I can do it right for free, they can do it correctly for pay, you know. That's all. I'm not trying to brag either. It's not hard to do right, is the thing. What I'm going to do is I'll take the dull side of this screwdriver. We're going to pull this O-ring out and probably let it have a break. All right, come on out, little buddy. You're going to be okay. We slowly relieve the tension on O-rings. Look at all that schmoo in there. Hard to find good help these days. That's funny, though. It's actually kind of true in airsoft. So in the last 10 years or so, because the technology has gotten so good, it's attracted a lot of attention, which generally means a lot of the younger, newer guys are trying to do some of the more difficult teching jobs because there's so much demand for it. I'm not saying by any means that I'm a super experienced tech. It's just I have a lot of outside knowledge that happens to pertain to airsoft. Like what you can mix with what and what you shouldn't mix with what. And that just happens to be really helpful in this particular instance because a lot of people shred their O-rings over time and they wonder why. Yes, I'm spilling isopropyl everywhere, but that's okay. We want to get things clean. So first I'm just trying to clean outside the cylinder body and the top of this, and that's easiest to do just while it's still attached. But now that we've gotten that a little bit loosened up, just kind of
get a lot of that out there. All right. We're going to... Hopefully this is long enough. Is it? Oh, darn diddly friggin' dang nabbit. Yeah, look, I mean, I don't know if you can see this. My bit is just barely too short. That's okay, I've got screwdrivers. Let's just see what I'm doing here. So this piston head has a screw and a little bushing that you have to loosen in order to get it to come out, which is good. Just kind of make sure it stays straight while it's in the gearbox and all that. All right, so we carefully remove that screw. That screw is unlike any other in the gearbox. Usually those are proprietary to the bearing within them. I tried measuring these before. To my understanding, they're like between M3 and M4, which is, oh my God, why would you do that? But this is all the other shmoo we're going to get out. All that white and gray stuff is lithium grease with gearbox bits in it. This is why we don't use bearings in our systems, because they're bad. And then they get grease like this everywhere. I'm also going to clean out the O-ring channel here. All right. Unfortunately, this might be one of those things where we have to say it's as good as I can get it. But dang nabbit if I'm not going to try real hard. Imperial-sized Allen key. I hate both systems simply because I have to buy 2 sets of tools. I could show you my wrench wall in a couple of seconds. There are 4 sets of wrenches here. There are 2 sets of 6-sided closed end for Imperial and metric. Those get used on automotive bolts quite a bit. And then there are 12-pointed Imperial and metric as well. And I have a larger set in the 12 points, obviously. Can't find 6 points hardly anymore. Hardly anywhere anymore. Okay. Got our little bushing washer thingamajigger. All right. So now all the CNC parts are pretty much clean. Nasty paper towel out, and now we change gloves. Oh, Lord have mercy. And we change gloves because we're going to add new grease with our hands. Dang nabbit, I'm not going to go through all of that cleaning just to put dirty grease from my old work onto the new work. Too much cleaning. Too much cleaning to screw up like that. All right. Come on, little nitrile glove. I should just have a big old bucket of talcum powder on the desk. I'll push my hands into it every time I change gloves. It is the bad thing about working with gloves is if you have to change, usually they're by glove set 2, you're just too sweaty to get gloves on in any reasonable amount of time. This takes too much effort. All right. Yeah. There we go. I've never seen a green silicone O-ring before, but that is interesting. That's what we have here. Never seen a green one. Just odd. But, okay, so take our fingers, kind of give that guy a quick once over. Take the PTFE. It's good stuff. Do 2 things. 1, come just barely out of the tip. I mean, just so you can see it domed. We go along the outside, and that's to not grease the O-ring, but to grease the sides of that piston head so that as they slide through that cylinder, there's not a bunch of wear on the plastic. I do use a plastic piston head simply for the reason that it lowers stress. Plastic tends to absorb that impact pretty well, whereas CNC aluminum obviously does not. It's a lot harder, which will put a stress point on the gearbox. And when you're using heavy springs like this particular one does, it just doesn't go well. you can tend to crack the front of the gearbox shell, which is a big pain in the butt. So I use a plastic piston head. Even at the spring weights and the types of stresses I've dealt with, I've never had a plastic piston head give me an issue. Here we go. So I've greased the piston head and this little O-ring. We're going to be pretty generous here. So no problem with putting a little too much grease in this particular spot. Now I just slowly work that guy back into place. I'll show you what the cool thing about these is. So these are ported piston heads. And what that means is that there are channels in this piston head. I think you see those holes there. There you go. Let's see if I can get some light maybe. Whatever. I'll hold it up. So you see there's some holes drilled in there, and those are channels that lead out to that ring. And once that ring swells with the PTFE I've put on it and the silicone oil, that'll be the chamber. Those chambers are what push the air through, and so it'll expand. It will open up that O-ring as it goes through, and you'll get a really good air seal at the end of the day because of that. Here's our actual piston body. This has some cutouts, just makes it light. Has a metal rack here. That's kind of important. They make them with plastic racks. They're lighter, but they tend to strip really bad. I don't have any bad wear on here. I would actually say this looks pretty great. So it really was just the one gear that was giving us problems. Good deal. Look, we found a positive thing. There's some people out there who think replacing this screw with an M3 or an M4 is one of those close enough type deals. I disagree. Because if this thing comes loose in the gearbox, you will lose 100% of your compression. And then you cannot be operated anymore, which sucks. Nobody likes having an airsoft gun that just straight up doesn't work. All right, so we drop these in. This is a really hard part to get aligned, unfortunately. Let me see if I can magnetize this screwdriver in. Really? Did you magnetize? Ah, it did. There we go. So we drop this guy in. We work the screw through the end there, just barely. See that screw protrudes out just a tiny bit. Just a tip, and only for a minute. I know, I'm hilarious. And a lot of people try and screw the gearbox shell onto it. I do not. Old-fashioned here. Not the gearbox shell. They try to screw that piston head from the inside of the piston. I don't. So the end of that piston head actually fits inside that tiny little hole. And then I give it a twist from the inside once it's seated. It's way easier that way for me. We don't over-torque that screw because there are plastic parts. Bad juju if you over-torque plastic parts. Most of us probably know that. Now we can test compression. So there's a nozzle here. There are O-rings inside here. I don't see any white grease coming out, which means that the compression was probably done correctly with silicone grease. I just dropped that part, dang nabbit. However, I was correct. There is no white grease on here, but I am going to clean it anyway because I just dropped it. This is another part that has O-rings. It should only receive the good type of grease, and this one looks like it did. Seems like the tech didn't take it out last time he worked on it and put the wrong grease on this particular part. But now that that's cleaned, get a little bit of the good schmoo, put her on there. Only takes a dab for this one. This is one where we don't really want a ton of grease because this part particularly shouldn't be lubricated. It should just be sealed. But we use this PTFE silicone grease because it helps that seal to form. Helps kind of swell that out. It is dirty in there. Let's see if we can get anything out. Growl? All right. Yeah, there we go. There's still some of that gray grossness from that, unfortunately, that bevel gear shredding on us. So we're going to get rid of that too. use some shop towels. This should be okay now. It looks like a pretty good finish. I actually do have lapping and cleaning equipment for polishing the insides of cylinders, but this one seems like it's pretty okay. I've got a pretty good shine here. So we're gonna put that back in. We want to feel a pretty good seal up there. So now what we do, I push that out just a little bit till it meets the bottom of that plate. Perfect. Now we test compression. That's what we want. We want it to be really, really hard for me to push that in. And it is. We've got almost perfect air seal there. I'm happy with that. I don't have an extra piston head or cylinder head to attach, so we're going to leave it as it is. We need to fix this and probably clean it. It looks awful. We're going to clean it. Got that gray grease just friggin' everywhere. Broken bearings are bad juju. Bad juju. It is a big pain in the neck to fix something like that sometimes. That spring's running away on me. You get to stay now. What I have here is called a tappet plate. Kind of hard to explain how this works, but this is just kind of an air seal mechanism that actually actuates. So the front of this has a nozzle, obviously, like everyone saw. But this tappet plate, that's what it's called, tappet plate. Tappet plate has a tappet nozzle that fits into it. This little guy goes here. And that fits over top of the cylinder nozzle. So the tappet nozzle over the cylinder nozzle. And what happens is, I'll grab the upper and maybe a barrel set to show you guys real quick. All right. So in the feeding of an airsoft gun, that tappet plate is going to actuate into the hop up when everything goes forward. And that helps to make a seal up against a rubber seal inside this unit. There's a BB in here, feeds from the bottom. Then once we're done with that actuating, it'll go back in on the seal. That'll just make it easier for BBs to feed. Once you have a gap of air, it's a lot easier to get BBs to feed correctly. Then the cylinder goes forward again, seals in the hop up, yada yada. I know it's kind of fragmented because you guys probably don't work with stuff of this shape really at all. It's kind of unique. But that does give you an idea of what these two different nozzles do. This air seal is the most important one. We will grease the back of this specifically so that it seals well against the nozzle face when we're actuating parts, because we do want that. We want that compression to break at the very, very last second, and having grease in there helps with that. Important thing, we're trying to get too much grease in that hole. That can be a problem. So we're going to go around the edge just very carefully. There we go. Now that we've got that, take my finger and pull off all the excess from the inside of that hole, just to make sure there's not really too much at all. On this side of the nozzle, it's on this side where it connects to the plate, not such an issue. On this side, it can be an issue because then you'll get that up into the hop-up chamber. And the hop-up chamber has a piece of rubber. I am dropping all of my caps today. I'll get it later. I'm going to have to put more grease in anyway. What the hop-up chamber has is a piece of rubber. In this case, it's actually silicone. That puts a backspin on a BB, so you get the Magnus effect, so that BB will resist the force of gravity over time, so it'll travel in a straighter path. And obviously putting grease on a friction-dependent surface would be a problem, so we don't put grease in the front of that. Let's see if I can grab that cap. I did grab it. There we go. Okay. Down you go. All right. We're helping hands here. Good deal. Okay, so it looks like we've got everything pretty much done. The last step here before I go and retrieve bearings or bushings. God, I'm not putting bearings in this. I hate that. Go and retrieve bushings is to clean out the bushing recesses. Can't JB weld in bushings if there is grease in them. So we use isopropyl to get rid of that. Can use also brake parts cleaner, but that tends to be really harsh on plastics. And it's also not very good at evaporating as fast as isopropyl is, which helps to just protect, again, that trigger board a little better. There we go. So what I want to see when I clean this is only the clean, flecked surface of the cast zinc alloy of that gearbox. Machined aluminum gearboxes do exist, but I'm kind of in the camp that says you don't really need to buy one unless you're having cracking problems. Obviously, any gun you buy is going to come stock with a gearbox, else it wouldn't be an airsoft gun. So I'm in the camp that doesn't really buy gearboxes until it's necessary. And this particular gearbox shell has held up just fine so far, so we'll keep it. Looks like we've got actually a little bit of a burr there. You get to see the fancy little spool Dremel stand. Got a spool here. It protects our Dremel wire. Comes in and out around that spool. So this is on a thread stand just for the simple fact that it keeps the cord out of the work. And we just take a tiny little bit of that burr off. There it goes. Gone is he. By a little burr. Need to be careful about when we do that because you will introduce shavings to the parts and whatnot. I really only ever do that unshielded with plastic if it's just a tiny, tiny little imperfection like that where the shavings are insignificant. My favorite burr to use on the Dremel is actually a conical burr. And it comes down to a point that's really good for getting to small spaces like that. It's very nice for pulling shmoo out of every which little corner. Because I promise you, if there is a corner of a gearbox, there will be shmoo in it. Clean up the next ones. I don't know if you're noticing, I am trying to use a different part of the paper towel for every single bushing hole here. Because these recesses do need to be pretty clean for adhesion to work well. Maybe a little more. And as wasteful as I think paper towel could be, this is kind of one of those instances where you really can't reuse a surface. So we try to buy recyclable and recycled shop towels. Not that hard to find anymore with that, the rise of recycled material, obviously. I know there's a lot of issues with recycling, but usually in the case of paper goods and paper, things like that, it's not nearly as severe as with metals. Metals are really get into that problem. At least as far as I know. If someone knows, you can correct me in the comments and feel free to educate me. But I do like the planet I was given, and I don't want to be the one to irrevocably destroy it. So, all that is to say, I try to do my best with paper towels and not being wasteful. A little bit dramatic to say, yeah, don't waste paper towel. All right. Just kind of giving this one last cursory look. I know these areas are going to get dirtied. Anywhere where I know moving parts are likely to be, just kind of give it a cursory look, clean it out. Best to remove. All right, that's it for part one. We're done cleaning out the gearbox shell. We've removed the old gears, taken a look at any of the damage, removed all of the really, really dirtied up bad grease, taken out the trigger mechanism, got our tappet plate somewhere. I don't know where the heck I put it. All right, it's over here. The tappet plate and selector plate have been removed and cleaned. We'll have to replace that sticker. I'll do that during part two. So far, so good. I don't see any extreme damage on any of the bearing holes themselves, so it looks like things are locked down at least okay in that area. I'm going to go pick up some bushings to replace these with, and I will see you back in a little bit. It's been fun. See you in a little bit, guys.